Okay, welcome to the SAICE Bridge Building competition. This is the 2021 edition in the Western Cape. We're really excited to be hosting this. Conditions are a little bit different from what we've had before. So we sent you kits by correspondence. You made bridges, and you can see the beautiful bridges there in the background. And now it's our opportunity to load them. So I first just want to thank, there are a number of sponsors who gave us donations to enable us to do this. Firstly, Alkaline for all that amazing glue that stuck your fingers together. Then to Bestwoods, who cut these little strips of wood for you so that you could make your bridges. And then a number of other companies, Asla Construction, Zutari, Hatch, JG Africa, Mark McDonald, Liners, and PRDW. So thank you to all of them for what they've given. Okay, so we're hoping this is going to be a really fun afternoon. We've got a whole bunch of volunteers who are going to be giving us some gears, but hopefully you'll be cheering along from home as well.
Alright, on the judges' side, we've gone through the bridges and we're looking for a number of different aspects. Firstly, well done to all the teams. They've done a great job. We've got a wonderful array of various different types of bridge, different structural styles. We can't wait to see how some of them perform. Some of them we know are going to do well, some of them we know are not going to do so well, that's fine. So what is the job of a bridge? It's to carry you across some crossing from A to B, but you also need to feel safe when you walk across that bridge. If you walked across a pedestrian bridge and it looked really poorly made and the joints were shoddy and it really looked rickety, you probably wouldn't walk across that bridge. So it's important that these things are well made, they're well designed, and they give you a bit of trust and a bit of confidence when you walk across. That's why we are putting aesthetics into the mix of this calculation of your result. So looking across, some of these guys have really done a great job of building symmetrical bridges, joints that are tidy, glue joints that are neat, bridges that really just give you a bit of inspiration and look like they're going to perform well. Whether or not they actually perform well is another story, but the look of it is important. The other thing we've gone through and we've done is we've weighed every bridge. Why do we weigh a bridge like this, and why is the weight of a bridge important? Well, the simple reason is that the weight is connected to the cost of the bridge. Timber, when you buy timber, it comes at a certain amount of rands per kilogram or per ton. So the more the bridge weighs, the heavier it is, the more it's going to cost when you actually build it. So if you can get away with a bridge that's nice and light, it's going to be nice and cheap. And the client who's paying for that bridge in the real world is going to be happy.
Hey, I'm Zutari and I'll be taking you to the reach system that will be for doing a bridge building. So first, we'll be having our weights right over here. The yellow is 2.5, the blue is 10 and the red is 5. We upload it here, over a pulley, all the way down here. And eventually we get to our bridge that will be placed over a specific distance. There's an apparatus that will help connect the bridge. And then we'll load the weights and see it break, and you will be enjoying that.
So this is for Santa Cruz High School 1. It's weighed in at, the judges are just going to grab the score sheet. For Santa Cruz 1,
296 grams.
296 grams. So this is a fairly heavy bridge. And it's quite a wide bridge.
A bit rough around the edges, a bit of loose glue showing. It won't really impact the strength of it, but it does make it look a bit rough. It's a well-designed bridge. It's very similar to what you would see out in practice. It's got some nice height to it. It's got some stairs and trusses and struts and ties. And yeah, I think we're ready to crush it.
Excellent.
Alright, some noise.
Damn, it's 40.
Get a zoomed in action shot. Stand back.
We're doing these two bridges first because they didn't quite meet the span requirement. So there's for Santa Cruz 2. And with their design, actually maybe you want to comment on it?
Yeah, you can see what they're going for. They had the Golden Gate Bridge or one of the bridges over New York in their mind. Unfortunately, this beautiful string probably won't help them because these members will actually want to, you'll see as it deflects, want to go into compression. And string, of course, doesn't do very well in compression. It's all about tension. But I must compliment them on a lovely little feature at the top here, which really adds a sort of nice aesthetic edge to it.
It's also worth noting that we've actually got a compound beam here, or a composite beam, which is not actually allowed. So you're not allowed to have many layers. This is a very strong member as a result because there are no spaces between. So this one will go for quite a while. 95.
We're going for 100?
We're going for 100. 100!
105. I think this.
Hey everybody, my name is Marianne. I'm a professor at the University of Cape Town and I'm the president-elect for SAICE, the South African Institution for Civil Engineering. I'm very passionate about making sure that everybody in school does maths and science so that you can learn how to build these type of bridges and then hopefully come into engineering and learn how to do it in practice. So I really hope that you are enjoying our live stream and that you are inspired to come and join us next year so that we can test your bridges.
Okay, so this is our next school, Rustenburg Girls High School. So we have 3 entries from Rustenburg. Really great to have them back in the competition. And yeah, the styles of bridges change quite a lot. Andrew, maybe you want to talk us through what's happening.
So already you can see just the weight of the rig alone is starting to act on this bridge. You can see the deflection going. You can also see, interestingly, that these lovely string sections are starting to sag. So again, these members should really have been designed for compression, not for tension as the ropes would have helped you. It's a very slender bridge. Because we've gone up to the full span and we're looking at single sections now, I think this will go at a low weight. So I would suggest the 2.5s to start off with.
Yeah.
But well done, it's well built, it looks good. Let's see what it does.
Cape Academy for Maths and Science, they are regular in the competition, we see them quite often. So it's great to have them from here represented. And yeah, Andrew, what do you think of this design?
So what we have is a very flat section. You were allowed to use up to 200 millimeters of height, and bridges, typically height is their friend. So they've lost a bit in terms of carrying capacity not using that height. But what they do have is a nice slender structure. And slender structures are also quite attractive and nice. So, well, I don't think this will carry a lot of load at all. In fact, it's started to fail already. I think we might have a 2.5 candidate here as well.
If you want to
let's close it up. Let's go for it.
Oh yeah, this is going to be fairly quick, so just load it very carefully. Well, it's holding, it's holding.
Here we go.
Okay, definitely got 2.5. We're right on the edge here.
When a fall.
And what's going to happen? Okay, so as you can see, there's quite an interesting aesthetic here. It looks creative, it looks fun. It might be the type of thing you see at Rectangle Junction or another place which would have interest. So, should we see what happens?
You need the triangulation, you need the struts and the ties to be able to activate that depth.
Yeah.
2 bridges ago, we had a very deep bridge from Rustenburg which crushed immediately because they weren't able to use that depth properly.
Yeah.
Go for it, guys.
This is going to be interesting.
Yeah.
There you go.
Yeah, absolutely.
We'll see. I think the real test is going to be what happens on the corners over here, whether there's enough reinforcing to prevent that from shearing. But it looks okay.
5s, I think.
There's noise.
And starting to deflect a bit.
Yeah. The top deck itself is starting to collapse.
Woo!
Very well. Very well.
Triangulation's holding it.
Some noises here. Sudden failure. Lovely. Well done.
might have to go through that.
Here it comes. You have compression. If you look down the line, you'll see a wavy. So we've got a nice high bridge, very slender sections. You maybe would have been better if it had doubled up or quadrupled up, but they're using the height nicely. The one thing to note, however, is because it's springing off these supports, you would rather have gone the other direction and put a nice little strut there in comparison. But still, looks good. Let's see how it does. If you look down the line, you'll see the wavy pattern of buckling members here.
37.5. 40.
And crushing it on top.
The official rule is that it needs to hold for 5 seconds, and when we get to the higher weight, we have to apply that.
Okay, so our next school, International School of Cape Town, they're 13.
And I'm told that this is from a year 7 class, 12 years old. So well done, guys.
10.
10's good.
12
and a half.
15.
15.
What? 15.
Team 1, rather. So Andrew, anything interesting about this bridge?
Yeah, quite a common design. You'll see this in sort of lower bridges across the country. A nice strut and tie arrangement. Obviously, those bridges aren't made out of thin pieces of pine. They're rather made out of very strong structural steel. But the form is good. Uses the height nicely. It's got a double section at the bottom. Seems to be well made. Let's go.
Cool.
Are we starting with 10?
Yeah, I think 10 will be fine.
Alright.
Then maybe onto the 5s after that.
Oh, geez.
10. Go with
But it's
5.
still there.
2.5.
Hanging on. 2.5, please.
12.
And you're already seeing some of the sections. Some of the stretch. Some of the stretch. Some are really holding tight and shattering, some are deflecting a lot. At some point you've got to say, even though the bridge is still standing, it's actually failed. If you walked across the pedestrian bridge and this thing dropped a meter while you were walking, it's not doing its job properly. So there is also a deflection limit that we should really be holding these bridges to, but for now it's a lot more fun to watch them shatter. It's a million-piece design. This is going to be one of the ones that we scratched our heads on. They potentially can be using an arch in between the supports. So how these connections here are going to perform at either end will be critical to the performance of this bridge.
Yeah.
They've used string kind of haphazardly to help in the joints, but you've already seen some other bridges that have failed at the joints before the sections go, so that might help them. Reminds me more of a roof truss than a bridge, but let's see. Surprised more teams don't use that. They're kicking off the arch.
14.
Well done.
Hi everyone, my name is Mudondi and I'm a civil engineer at Zutari Consulting Engineers. I was part of the bridge building committee for setting up this competition. As you can see, we have a virtual thing going on. The competition usually took place at Canal Walk, in-person competition where the students built the bridges at the location, but now the bridges were built at home and were sent here, and now we're doing the bridge bridge breaking. We have a whole live setup going on, some camera equipment and some lighting. We have Tebo here handling the Facebook live stream and the scoring. So it's a very interesting setup that we got going on here, and it was also a great opportunity for schools that never participated to participate, which is very fun, and we're looking to do this more in the future.
The students were tasked to design a proposal bridge of the N7 Oliphant River Bridge. this was all done on a software package called Bridge Designer, which is easy to learn and very insightful in terms of cost and the inner workings of a bridge, that being the forces and material characteristics. This is very insightful to students that are looking to venture into engineering as they move on to university. We highly encourage you guys to try it out next year and see you there.
The results for this year's digital competition, in third place we have Brackenfell High, Team 2, with a cost price of $439,000, and coming in at second is Rustenburg Girls High, Team 1, with a cost price of $179,000. And the winner for this year is Weinberg Boys High, just beating Rustenburg Girls High by $600, with a price of $178,000.
I like the second line across there. It adds a certain aesthetic to the design. Andrew, what do you think?
Yeah, good some principles. Some nice triangulation. It would have been more effective if this section had continued all the way. You can see it's kind of broken with a joint and then it continues. So there could be some weak points here. Similarly on the top, I don't know if you can see with the camera angle, some of these cross members have been made up of shorter members that have been glued together. So wherever there's a joint, there's a potential weak spot. So ideally you want long, straight runs that are undivided. But of course you're limited with your materials, so you make do with what you can. So there we go. Let's continue. Starting to deflect. You can see there's an opening here. Weak point.
But this is a compound beam, which is not really allowed, where you've glued many pieces over each other. It just obviously makes them that much stronger as an individual piece. So, you know, this bridge may have been disqualified if it was a contender. But anyways, try to avoid this. You can have two pieces with a short space in between. That's allowed. In fact, it's better because it makes it lighter and it's allowed. So
okay, Islamia College, team number 3.
Exactly. This is like the further fourth bridge. It's kind of got that.
Yes,
yeah.
So if you really wanted to work to its full capacity, you'd ideally be kicking off your supports here with these sort of low struts. Unfortunately, they're a bit short, so they won't really activate until they're deflected enough to start pushing against. The bridge is a composite arch, but still, right principles. Nice height, nice connections, lots of triangulation. And a double section for the main deck as well, so yeah. Let's go. Let's start with 5, shall we?
5.
Again, you say all the compression will go into this top section and we'll start the button on the top. Sun Valley, well done, Islamic College. 35.
So yeah, 35.
I'll tell you, I like the principle of putting your name on a bridge. Imagine if you were an actual bridge designer. Would you be willing to put your name on that bridge? Maybe your street address?
Someone said engineers should start putting their names on the infrastructure. So
and they should stand underneath it when it's built. Yeah, that's right. Good looking bridge. You've got large triangles broken up with smaller triangles. I think this will do alright. Let's go, shall we? 5 kilograms. Starting to deflect already. There's potentially a weak point on the left hand. And we go. Okay. I think that had a particularly weak joint on the one side. Unfortunate, but this is how we learn. I hope we're all having fun. Not the most symmetric repeating design. And a couple of these longer sections have been made up of more than one piece. Also, if you wanted to make it stronger, you would have gone for a double or a quadruple section, especially over the top. But a nice arch bridge, triangles are going the right way. Looks like it will take a little bit of load. Let's see.
15.
And then one of these joints will go soon. Sudden failure. We'll pop that on the front. Alright. Rustenburg, come on Rusty Bugs, another team. Let's see if they earned their first team status. Awesome, full height, nice. I don't know how much help these string connection additions are going to be, but lovely triangles, especially over here where all the load's going to get taken. Double section at the main deck. Let's go for 5, shall we? Rustenburg goals, let's see how we do.
60.
60, okay, I think this is doing very well. Well done. Blind, we'll see if that plays a part or not. But importantly, you see this double section going over the top. And from here in the nozzle, you'll see the guys flip from singles to doubles to quadruples to really get that section activated and working, because that's going to be the arch that does all the work. Alright, Rustenburg girls, let's go for. Now we're going more than 2.5. Have some faith. 5, shall we? Yeah. Please don't break, please don't break, please don't break. 5, one of the joints, you can just hear it's gone. I think we're... near the end, yep. Alright. Okay, once again an arch. I'm not too sure what this is all about, maybe just a pretty feature. But a nice big arch, full height being used, long sections. Now, if you were to break that up with a nice inter-triangulation story, it would be better for the strength, because the longer this thing is, the more likely it's going to buckle and break. But nice double section, nice triple section it looks like on the deck here. I think this will do alright. DF Milan. 50 already, well done DF Milan. Okay. Okay, it's starting to deflect. Jeff just jinxed it. Alright, Weinberg Boys High School, here we go. Lots of triangulation here, lots of activity. A single section at the bottom, which I don't know if it'll be a problem or not. That's going to go into tension. This is going to want to compress. Lots of inter-bracing. 60, well done. Holding on for dear life.
60.
Well done, my big boys. Catastrophic sudden failure. These sections are going to start flying. If you can zoom in and have a look. Now we're on to quadruple sections. Rack and fell high. Typically they do very well at these competitions. They've done this before. They know what they're doing. And they put a lot of their resources, a lot of their available timber into this main section on the top. To be honest, the building of this is a bit wonky. It costs you a little bit of points on the aesthetics and the construction value. You can even see it's not really seated properly, but the principle is good. We've got 4 sections here. They've got spaces in, well triangulated, using the full height available to them. What they haven't done is they haven't introduced any sort of transverse bracing in between here. That might cost them. We'll see. Now we're into the big leagues here, guys. Takes it to 200.
Seat in there. Very well. That's the ratio exceeded.
These guys have thought through the design. Good connections, 4 sections. I think this has actually got 3 going over the top. They've doubled up the section here where the load's going to go. And the question was put, what then differentiates this design to the other 2? I don't know. It might come down to the strength of a joint. It might come down to a single weakness in a piece of timber. As you know, it grows on trees. There are knots and there are all sorts of things happening inside a piece of timber. Right now it's a bit of a guessing game, but I do think this should do well based on the design, and I think we'll see some heavy loads here as well. 237, 240, that's incredible! 245.
Close your eyes.
247. 257. How much? 250. 250. 255. Guys, I hope you all had fun. I hope you enjoyed This project, it's been a sort of micro example of what it's like to work in the real world. You've had restraints, you've had budget, you've had time to use, you've had team members you've got to work with, you've had a deliverable you've got to put out, and now you've seen it in practice. I hope it hasn't been a waste of an afternoon, even if your bridge did collapse at 2.5 kilograms, or if it went to 250 kilograms, I hope it's been a learning experience all the same. This last bridge, Brackenfell High, very similar design to their two teammates. It's got 4 sections at the top, maybe a slightly less smooth arch. I don't know if that'll feature in its result, but I think this will go, it'll do fairly well. Crack on, team, let's go, 10.
10, 15.
After a certain amount of load, it just takes it anyway, we'll settle it out. Wow, what happened there? Where that failure point was. So the design can be as good as you want, you've got to make sure all these joints are strong as well. Good spot, very well done.
So we'd like to keep running the digital competition in the background too. Not every school entered, but thank you to those who did. There is prize money for it, so please consider entering next year. Okay, well, with that, I just want to thank everyone who's helped. I want to thank the sponsors once again, ASLA, who gave us a financial donation, along with Zutari and Hatch, MPA Mott, PRDW, Liners, and JG Africa. And also thank you so much to Alkaline and to Bestwoods, who helped us provide the materials for this event. Okay, thank you very much. Please take care and enjoy the rest.
In real life, you won't have to